Dear students, welcome to the session of Civil Engineering, Societal and Global Impact. Till now we have discussed all the things which are traditional method used for the solid waste management. Now, in this session, we are going to discuss about the futuristic methods and the innovative technologies which can be used for the solid waste handling. The smart technologies which we can use for the solid waste management, which is very helpful to the environment and which will not create any hazardous things to the environment. Now, the traditional method, let's recall of the last session that we have discussed about the shredding and pulverization, we have discussed about the incineration, we have discussed about the pyrolysis and the compositing method. So these are the methods which we have discussed actually, which are traditionally used for the day-to-day management of solid waste. Now we are going to see of the futuristic things, right? Yes, the major portion we are also going to see about the water purification methods. Let's discuss in detail. First of all, the solid waste management, the very first method is known as refuse-derived cell, that is refuse-derived fuel, right? What is that? It makes the waste very much useful. This is basically produce the process of municipal solid waste, that is the day-to-day life. Now you can see here, I have shown here the figure. Look at the figure, what does it mean? Firstly, the refuse is used. Then we have the primary scaling. We have the drying of it, classifying towards it. So basically what we do, we are segregating the waste because we need to make the refuse derived fuel cell, right? So you can see here that in the primary thing it is being crushed, then we are doing the drying process of it, then you can see that we are classifying towards it. What is required in the primary will go to the secondary, and again the purification will be done, and hence we are going to have the RDF petals, and then we have the refuse derived fuels. First 4 days, the waste is kept under the temperature between 60 to 65%, which is increased to 70%. So we keep according to the temperature. We see the properties of temperature according to the material, that how it is changing, what are the changes is taking place. So basically it is classified in the mechanical biological treatment. And lastly, we get some organic matter which we can use. Now we also do from this the removal of steel cans which are not required into the material process, right? So this is refuse derived, which is the futuristic method for solid waste management. But in a large scale, where we are going to use this, how it is useful to it, what can be done towards this scale, and what is the day-to-day useful of these things, we need to see this in detail. Now let's see the other method which is known as the fluidized technology. What is this fluidized technology? It is known as fluidized bed reactor. Again, this is the machine which is used and which has been generated that solid waste is being heated up to the large extent of temperature. And let's see what happens towards that. So basically, for gasification of finely classified waste, fluidized bed reactor are being used. Combustion process of uniform fuel including raw lignite, coal and sewage sludge etc. is used. Vertical cylinders are used. You can see here the lower section of bed is inert material are fluidized with air. Waste is fed into the fluidized sand bed. Bed plate has hole which allows the preheat air to enter the combustion chamber. Now let's see what is being done. Look at to the figure. Here into the figure you see feed hopper. They have kept into it is the rice husk. The remaining of the rice is being filled up into the vertical cylinder. Then you can see there is a blower, there is a cyclone, gas burner. Heat is provided into the vertical cylinder, and you can see there is a gasifier reactor into it. The reaction will take place when temperature is high, and after that you can see with the chimney hopper it moves out. Even the heat is provided, and now you can see that what does it create and how it can helpful. Now the air, it goes into the chimney. Now we need to see that does it harm to the environment or not. So this basically is used for the organic matter which is generated. It is even the costly thing because not much ton of waste is being solidified into it. Now let's see to the next method which is known as bioconversion and bioreactor. Bioconversion means it is for the food basically, right? So here the food energy recovery, currently food waste and other combustible waste are collectively incinerated and landfilled. Valorization is used for the production of hydrogen, ethanol, biodiesel and biogas. Basically the food which is we are wasting it, and what can be done towards the bioconversion. Basically, it can be helpful for the biogas, biodiesel, ethanol, etc. So we do the landfilling of it, and then we provide the heat towards it according to the temperature required, and then we produce some biogas or some biodiesel which can be useful in day-to-day life. Now let's discuss about the bioreactor. It enhances the rate of decomposition circular of leachate. Means the waste, the liquid waste, the bio waste of from the food, from the domestic purpose, from the kitchen waste is used. You can see here it moves towards the tank, that is the reactor. You can see here sensor probe, thermal jackets and the reactor tanks. In this, with the high heat or with the air went into it, it will react and it will change the property of it, increasing the growth of microbes, and which decomposes municipal waste. Waste is dried by conventional landfilling technology. So basically the slide background, if you can see right at this moment, is basically the bioreactor background which I have shown. You keep the waste, you provide the temperature, you have the water, you have the air, and it will change the property and basically it will decompose, right? And it can be dried also. Now that can be used in our agriculture purpose also. The food waste only, the organic waste only can be used if we provide the some chemical reaction towards it. Now let's discuss the landfilling gas recovery technologies. What is landfilling? We have already discussed in last session also, and we are discussing in here in detail. Landfill gas recovery technologies, basically when we spread any waste into the landfill, it creates some gases. And how it can recover? Does it help to us or does it give hazardous things to us? Varied due to the geological, hydrological, geotechnical properties which have environmental impact. Biotic and abiotic factor will lead to the generation of gas at landfill, which is combination of CH4 and CO2, that is methane and carbon dioxide. Chemical oxidation produces a biotic gas in presence of water and metal like aluminium, right? So this gas causes damage and that should be taken care of it, because it will lead to the global warming both as gases are greenhouse, right? So which are the technologies can be used towards it? First technology is microturbine technology and second is fuel cell technology. Let's see what is microturbine. Is generation of electricity from the landfill gases. Supply of electricity to small scale by nearby projects. And global warming, it helps to resolve the issue of air pollution and global warming. So in the biotechnology, microturbine technology, basically we generate the electricity from the gases of landfill, right? I cannot show you here the picture which was not properly clear to make you the sense, because they are just showing is the improvement, that is what is landfill recovery gas. So I have not shown here the microturbine technology image, right? So it is just a thing which is generated from the gases which are collected from the landfill, the material which we have disposed, and we have tried for the electricity provisions and we are giving it to the small scale, right? So basically in the villages it can be tried. Now let's see the other method which is known as for the fuel cell technology. What is actually the fuel cell technology? Basically here the fuel cell technology, if you discuss, it means energy from fuel is converted into electrical energy in electrochemical cell is called fuel cell. Fuel supply oxidizing agent reaction. Now here in fuel cell you have seen the oxidation and reduction process actually. The oxidation and reduction process actually take place in such a way that it needs that fuel is reconverted into the electrical energy. This is just what we are trying actually. It is not the process which we are using in our day-to-day life. But yes, this is just that through the landfill gases we can use in some other ways. Right? Generation of transportation for fuel cars and buses without combustion is application of fuel cell. We can apply this technology towards the fuel cell. So this is basically the microturbine and fuel cell technology. Now moving further towards the smart waste technology and transformation in waste industries. Let's discuss in detail that what is smart waste technologies and transformation in waste industries. Now, you can see here that are the things which we are day to day using it up. Let's discuss first the smart waste technologies. The very first smart waste technology is electric garbage trucks, smart garbage cans, trash collecting robots, RFID tags, and eco ATMs. Basically, here, the electric garbage trucks are provided, which is manufactured by like Tesla, and more electric cars are crowd the automobile market. So therefore, the garbage truck will be replacing the traditional garbage truck with the electric one, which reduce the fuel consumption by 67% in vehicle maintenance cost. This is the good thing which we can do, and we can reduce many of the waste. Let's look towards the smart garbage cans. Basically, it measures how full garbage cans are in order to inform local waste management. So garbage can be known by the technologies that garbage has some identities, that is a smart garbage. Once it's full, it can be said to that other garbage cans to be given. That is can be handled by the local governing body actually. Right? So basically encountering the empty containers and we are giving that how much trash can be collected actually. That is the smart garbage. Once it is full, it will automatically say and keep the sensors that which are the other empty garbage, so it does not create problem to us. Basically next is trash collecting cans. Automated garbage collection robots can be expected in the near future, contribution to the certain of even more efficient waste management system. Volvo and several partners are looking into it. There is a robot based that it will collect the trash and collecting robots that will collect the steel waste and all hard material waste actually. Lastly, you can see RFID tags. In order to reduce the waste, RFID tags have been introduced in numerous communities to provide recipients. How much waste you are generating, the tags are given towards it. So people might look towards it, how to minimize and reduce the waste generation and what are the future technologies coming up. Lastly, we are going to see eco ATM, how we have the ATM. Basically, we have the ATMs towards that when we do the e-waste management. That when we are trashing the mobile phones, we need to do the eco ATM. So smart e-waste recycling bins are currently being trailered in Australia, but US company has gone one step further. Eco ATM has almost 3,000 kiosks across US that can automatically identify thousands of different models of old electronic device and instant payment of them. So old devices are basically what disposed of. Right? Now let's discuss about the transformation in waste industry right now coming up. Improved recycling rates, automated waste collections. Yes, what we have discussed. Route optimization that can be done with the robot thing coming up for the collecting trends. Landfill modernization. Yes, with the landfill recovery gas, we need to also look into the landfill modernization. What in the future can help to us. Next is enhanced safety is the major question. Hazardous materials should not be disposed into the environment. Quick turnaround times. What are the quick turnaround times? What are the technologies? How it can be implemented to the other sectors? Right. So these are the things which are coming up with the smart technologies in solid waste. Now let's discuss about the conventional method of water purification. You can see and you are aware of all these methods. What are that? Boiling of water, which is very conventional and traditional method. We are doing it because it kills the bacteria. Similarly, before drinking, we do the boiling of water. But looking to that, we use other method which is also the traditional excess lime method treatment. When the pH of water is above 9.5, E. coli bacteria in water will die. When enough of lime is added to bring the pH to this figure, right? So basically, this is not used for the public. This is can be only used for removing bacteria from the sterilized water if it is required in hospital also or any other chemical treatment. Next, we are going to see treatment with iodine and bromide. It has been seen the addition of iodine and bromide kills the bacteria and all the pathogenic bacteria. The quantity of iodine and bromide should not exceed 8 ppm. It is basically used in the industrial wastewater. So it can make the hazardous material to be removed from it. So basically water and this iodine and bromide react with each other. Treatment with ozone, it is a gaseous form. Yes, you have seen oxidation and reduction process takes place. Basically ozone is nothing but the unstable allotropic form of oxygen. by passing with the high tension electric current through the stream of air in a closed chamber. It will clear the bacteria from the water. Treatment from ultraviolet rays, UV are the invisible. Yes, right now there is a treatment which is very much coming up into the trends. That in the sun rays are provided which kill and disinfect the water. These technologies are inbuilt with the RO plants and the aquaguards which we are day to day using, but not into the use because it was a conventional method which was costly actually. So we have come up with many futuristic and innovative methods of water purification. Treatment with potassium permanganate. Here, the water is dug out from the well, and with that, some amount of potassium permanganate is added into the bucket, and then the bacteria is killed towards it. Even the municipal corporation right now providing us some of the other medicines of that which should be kept into our drinking waters, and that will reduce the bacteria which are harmful to our body. Right? So basically, that tablets are of potassium permanganate only. Treatment with silver called electrocatering process. In this, metallic silver ion are introduced into the water by passing it through the tube containing solid silver electrode which connect to the DC supply of 1.5 volt. So basically it will remove the bacteria from it. With all this method, these are the traditional and conventional which till now we are using it up, but not the 100% bacteria and pathogens can be eradicated from the water. So we need to look further that what other technologies can be used. These are the traditional 7 technologies which we have used, which we are using and which also been used in the rural areas right now. Right? So next we are going to see about that what is chlorination. We all are aware of that chlorination is very important and that process is provided towards our water to eradicate the bacteria from it. Let's discuss first of all, there are several stages of chlorination. First, we are going to see the plain chlorination. This chlorination process is very important. Types of chlorination is also important, that how and which sense we are giving. So basically, first discuss about the plain chlorination. Only chlorine treatment is given to the distribution system of 0.5 mg per liter added to the water. So basically, water which is coming to our home is being chlorinated. First is the plain chlorination. According to the water properties, we do the chlorination process. Next, we are going to do the pre-chlorination. Before filtration, chlorine to water before its treatment, especially before filtration process. Next is post-chlorination. Here, chlorine is added after filtration is adopted before water enters into the distribution network. Next, there is a double chlorination process. Applying chlorine at 2 to 3 points in the purification process, this required when water is highly contaminated. So this process, basically local governing body is applying towards our water which is supplied to our houses. That is from the Narmada water or any other river water, right? Mahi river water, which are water coming to the cities will be done with the chlorination process, which is very important. So plain chlorination, pre, post, double. Let's do the breakpoint chlorination. This point comes when chlorination is not much required beyond that level. So idea of extent of chlorine added to the water, that much dose of chlorination beyond which any further addition will appear as free residuals. To some limit with the water properties, we cannot add much of the chlorine, which is known as breakpoint chlorination. Beyond that extent, you cannot add the chlorine. Last is the superchlorination. What is superchlorination? Application of chlorine beyond break stage, highly polluted water, strong odor and taste of chlorine. So basically we provide the excess of chlorine, that is the superchlorine to our water. So with the water purification technique, we have also seen the stages and the types of chlorination, which is very important because chlorine is important towards it. If we look to the example of chlorination water of swimming pools, yes, which is very much required because in the general and normal water you cannot go and stay. It will create a problem towards your skin. So these are the types of chlorination. Now we are going to see of the futuristic and innovation methods of water purification. Which are the futuristic and innovation methods of water purification? You can see here the futuristic and innovative methods is the nanofilter, toxic eating bacteria, Medidrop ceramic water purification disc, water purification filters, removing arsenic with plastic bottles, reverse osmosis, UF purification and UV purification. These are the technologies we are using. So nanofilters. Nanofilters are the filters which we are providing, and through that we do the water purification. the toxic eating bacteria which is microcystin contain will remove all the salty, organic and fulgaric fungi from the water. Right? Medidrop is the ceramic water purification called Medidrop. The tablet of small ceramic disc is impregnated with silver or copper nanoparticles. Right? Similarly, Medidrop filters are used, which will remove. The filters are made of local clay, sawdust, and water. This material are mixed and pressed into the mold and then fired in a kiln. So these materials are basically used to do the purification of water. Removing arsenic with plastic bottles. With the plastic bottles, we can remove the hazardous materials from the by crushing to the can, chop into the ordinary plastic beverages bottle coated with cystine and amino acid nutrient found. Last is reverse osmosis. This process we are everywhere using it. We have the membrane layer, water passes through that. What is required stays, what is not required is disposed of. Reverse osmosis, which is known as OS, RO, which we are everywhere using, right? So reverse osmosis is the process in everyday life with the domestic help and the supplies of water at our home. We are using it, right? So we remove the required, non-required pathogenic bacteria and the solids from that, and required will stay into it, and we can use for our day-to-day life. Last is the UF purification. This membrane removes impurities like particulate matter, pathogenic organic. UF water purifier works by physically removing all the germs and bacteria present into it. And lastly, you can see UV purification. It is the UV light which kills 99 to 99% of bacteria, and water which is required will stay, and present in the water of harmful organism will be destroyed. So these are the water purification techniques which we are using in day-to-day life. Okay, so now let's recall in the last session what we have done. We have seen about the water conventional water purification techniques. We have seen the smart and innovation future techniques for the solid waste management, and we have seen that what are the future innovation techniques for the water purification which are helpful in our day-to-day life. So this session basically contains of smart waste management, how we do the smart waste, what are the futuristic technologies, in what scale you can use your smart solid waste management in a smarter future technologies, and in which sector we can apply all the solid waste management. Other than construction, you have also seen that fuel consumption for the cars and vehicles can be used. So this is how you need to know about it. Even the water is a major question, and we have seen what are the conventional methods, what are the methods for landfill gas recovery, which is also important because it should not create any hazardous things, right? So this is all is very helpful in our day-to-day life, and we need to look about it. In the further sessions, we are going to see about what is wastewater management and how is the treatment to the wastewater, what are the hazardous air pollution affecting towards environment. We are going to see in the further session. Thank you. I hope you are clear with the topics till now of the conventional method of solid waste management, futuristic methods of solid waste management, and the water purification technologies, that is conventional, and the things which we are coming up with the futuristic smart innovations in water purification. Right? Thank you.